Okay, so in this question they want us to find the volume of sodium hydroxide used. The volume of sodium hydroxide used to titrate, in other words, to neutralize the excess acid. So how do we go about that? So in this case, what we have are the two equations. We have got equation 1. So equation 1 is dealing with calcium carbonate, okay, aqueous, plus the HCl. So this will basically give us a salt, which is calcium chloride, plus water, plus carbon dioxide. So if you are moving forward, it means we need to start from the first equation going to the second equation when they're asking about the reactant or the reagent which is in the second equation. So they're saying if 0.205 grams sample of calcium carbonate with that molar mass is added to a flask along with 7.5 mils of 2 molar HCl, then enough water was added to make a 125 ml solution. After that, then they got the aliquot of that solution, which was made, which is in the 125 ml, and then it was taken and titrated with the 0.058 molar sodium hydroxide according to that equation. How many mils of sodium hydroxide were used? So in this case, we are going to start from, we are moving forward, not backward. So we'll start from what we have. The whole point is that we need to find the moles of sodium hydroxide that reacted with excess HCl. So how do we get there? First of all, we need to know how many moles of HCl remained in in excess. How can we do that? First of all, what information do we have? We need to find the available moles for each so that we know how many moles of HCl reacted. To do that, we need to find the moles of calcium carbonate. So if you are given mass, okay, to find the number of moles, we say mass over what? Molar mass. So in this case, the mass is 0.205 grams over the molar mass. We've been told that it is 100 grams per mole. So we can punch that. What are we going to have when we punch?
(2.05 times 10 to the power negative 3).
2.05 times 10 to the power negative 3 moles. So these are the available moles of calcium carbonate given. You can also do the same and find the moles of HCl given. So we are given concentration times what? Volume. So you do the same. The concentration is 2. The volume is 7.50. Remember, it has to be converted to liters. So this will basically give you 0.015 moles. So these were the available moles, okay, for each. So now, how do we then find the number of moles of HCl that reacted? So to find the moles of HCl that reacted from what you've been given, you use stoichiometric ratio. So the mole ratio between calcium carbonate and HCl, the mole ratio is what? 1 to 2. So since the mole ratio is 1 to 2, we are going to say, how about these moles? of HCl, which is of calcium carbonate, will give us how many moles of this. So the assumption is that at this point you already know that HCl is in excess, therefore the number of moles of HCl that reacted, we need to find X. So you basically just have to multiply that by 2. When you cross multiply here, so you are going to have 4.096 times 10 to the power negative 3 moles. So now, remember what we said, how can we find the excess moles? We developed a formula for calculating the excess moles. How can we find the excess moles? The formula is number of moles of HCl in excess is equal to its available moles, the number of moles added, okay, of HCl minus the moles of HCl that did what? That reacted. So this is the formula. So what do we have? The available moles, we've been told that it is for HCl it is 0.015 minus the reacted one is 4.096 times 10 to the power negative 3. So what are we going to have when we subtract?
Zero point 0.0109.
0.0109 moles. So it means we have reached this point here. Now they are saying a 10 ml aliquot of this solution. So these number of moles we have found, they are in what? They are in 125 mils of that solution that you made the excess moles that you have. So we need to scale it down to what? To 10 mils. So if you say that 0.019 is in 125 mils, how many moles would be in what? In 10 mils. So we need to find the moles that will be in what? In 10 mils. So we are going to scale it down. Scale down. So you say, since we are dealing with the aliquot, you say, actually, this 0.01909, this is in 125 mils. So how many moles will be in 10 mils? Then you cross multiply, find the value of what? X. So in the aliquot now, so this will be in 10 mil aliquot. How many mils are we going to have in 10 mils aliquot?
8.72 times 10 to the power negative 4.
8.72 times 10 to the power negative 4. So meaning that these are the moles that we got at this point. They are the moles we got in 10 mils aliquot that we titrated with what? That solution. So these were the excess moles that we got. Therefore, at this point, we just have to look at the equation to say, how is the equation of the excess moles? So this is reacting as what? Sodium hydroxide, HCl. This will give us sodium chloride plus water. So now this is a one-to-one equation. What it basically means is that the number of moles number of moles of sodium hydroxide will be equal to what? The number of moles of HCl that we found. So, and we found that the number of moles of HCl in excess after scaling it down is 8.72 to the power negative 4. So since you have the number of moles and we were given the concentration, which is that, we know to say number of moles is equal to concentration times what? Volume. So to find volume will be equal to number of moles over the concentration. So the number of moles is 8.72 times 10 to the power negative 4 over the concentration is 0.058. So what are we going to have? Someone to punch for us?
0.15.
So it will be 0.15 or 0.0.
Let me try to punch again.
Is Mr. Tsanga, are you in class?
Very much so, I'm following.
Okay. You don't have a calculator?
Let me grab one.
Alright, so this is the context of this question. Yesterday we were moving backward all the way to the reactants we started with. But in this case, you are starting from the reactant all the way to the what? The product. So what do we have now?
0.015
liters. So if you want, you can convert this to mils, which is basically just 15 mils. So that is how you needed to calculate that question.
Thank you.
Right, so now let's look at redox, balancing redox reaction. Balancing redox reaction. So you can balance redox reaction either in acidic media or basic water media.